Good morning and happy Tuesday. I'm planning on doing the Leak Code Daily Challenge for today, September 12th. Let me share my screen here. Okay, so here we go. The 12th. Minimum deletions make the character frequencies unique. Same frequency. Two deletions. Okay. Oh, I already came up with a solution here. Hold on. Before I take too quick a look. All right. Solved this one before. Okay, so let's see. I solved it about a year ago. And then a couple years before that. So anyhow, it is 6:02 in the AM. And the game plan is this. Use a map M as a counter for each character C frequency. Then return the accumulated sum of each frequency minus the minimum frequency, which would be the bottleneck. Okay, so that's the game plan. Let's start implementing it. Took about 1 minute for that. 6:03 implementation. I'll just say this is an array of characters. Okay, and then M is a counter. These characters. Low is the minimum value. Return the accumulated sum of M sub k minus low for k and m dot keys, something like that, right? Oh, for k and m dot keys. Oh, well, it should be 0. S is already good. Oh, they don't have the same frequency. I see. Okay. Oh, it's okay. I misread this. Okay, so hold on. Misread. Problem with statement. Okay, so each one has to be unique. And we have to minimum characters need to delete to make us good. Frequency of 0 is ignored. Is this one? Example 3. Array of characters. How many are there? M sub C equals 2. M sub A equals 2. No, A is 3. M sub E is 1. M sub B equals 2. Okay, so how many do you have to delete? Down to what's been previously seen. 25. If there's the same frequency, we have to delete it, right? Values with the same bucket need to be altered, right? This guy goes down to 0. Or we can just stick them into buckets. Let's see, bucket for right, the key and value in the map. Bucket, here, let's just do this default dictionary based. So k dot bucket the value. Right, so this associates them in reverse, the value in the character. Or which value in buckets. Bucket keys. So if there's multiple with that same count, let's do this character count of a character and the count. It's the count, open the character there. It's the count, and then we have characters per count, right? And so if it's more than one, that's when we need to reduce it. Suppose we can do these from low to high. All right, so do this guy first. We have one. Scene values would be a set of one lookups. If count and scene, that's when we have a problem. To reduce each of these things, right? The largest value not yet seen. Well, I guess we can reduce this incrementally and then we'll have to update it so to the TLE. T is our total deletions will return at the end here. We know each of the keys needs to be moved. For each character, we need to delete it one at a time. And it equals the count. Count minus one. Just this, wow. Candidate is in scene. Candidate minus equals one. So we'll have to update this maybe using binary search or something more clever, I think. Otherwise, it's going to TLE for the count in the sorted buckets. So we start with the lowest ones and go up to the higher ones. Counts unseen. We have to update each character in this bucket until the count is not seen. See, so here's our candidate count. What we need is we need to update all those. This is the length of the bucket for that count. All right, so this is all the characters that need to be updated. While need and the candidates in scene. I'll need if candidate is not in scene, then need minus equals 1. Scene to add the candidate. It's already been seen. We need to update this many characters. The candidate count is decremented by 1, and total is incremented by 1 each time we decrement the candidate. And this simulating deletion of that character frequency. Candidate is not in scene. We'll take it. Count is in scene. Otherwise, if it's not, scene to add count. Only if it's already been seen. Okay, let's see what happens here. Example 1, frequency is 2 and then 1, so that's 0. Example 2, we have 2 with the same frequency of 3. So 3 is used, 2 is already consumed since we're doing it from the bottom up. Okay, I think this looks good. Oh, that's not right. Oh, I'm only processing count once. So I need to do character and then count. I see. Okay, oops. All right, hold on. I'm not sure how helpful this bucket thing is. Then here's a counter. Scene will be our set. They're associated, right? So stick them on the same line. Then this is the character. Character and count. Count has already been seen. And we need to update just this one, right? Well, the candidate's been seen. We'll decrement by 1. That's a deletion. Seen to add the candidate. So for each character count, if the count for the character has been seen, candidate count will be decremented by 1 each time it's been seen. Candidate, it can zero out. If it's zeroed out, then this would return false. Okay, let's try this again. Keep it super simple. I didn't need the bucket, right? Oh, sorted character count items. Oh crap, hold on. We want it to be, I do want it sorted in the other way, right? I don't want to process the smallest ones first. Yeah, we can do this, I think. E equals come to E lambda AP A sub 1 minus B sub 1 if A sub 0 yeah, let's do that. Sort it by the frequency, that is the count in ascending order. So we should process the B1 before the A2. Let's see. Should be cool, right? So if you have A, B, and a C, then it should be 1. It's good. Add the count here. Oops, come on. Second time through, the count should be previously seen. Okay. Should be 2. Looks good. In this guy, I have to zero out one of them, right? This is the case for this guy. I have to zero out one of these 2s. Okay, so that should, I think this will TLE, right? Pretty sure this will TLE. Oh, no way. Candidate counts. Surprisingly, it doesn't TLE. Okay, well, it's accepted at 6:20. About 18 minutes. Oops, 18 minutes for implementation. Oops. Implementation and implementation in Python 3, which is accepted. Yay. So I misread the problem statement, kind of made it more complex than it needed to be, having a bucket as well as a counter. The bucket ended up being the opposite association. So like the counter was a character to the frequency. This is frequency to character into a bucket of characters per frequency. But that seems to be overkill, right? This is sufficient. Have a map, keep track of the counts, which are the individual frequencies that have been seen. The candidate, which hasn't been seen, is basically decremented by 1. Super simple algorithm, which I thought would TLE. I'm really surprised. Maybe since we're processing it from the bottom of it, that's fine. I want to keep it as super simple as possible, and this is a more simple solution, right? This is like overly complex, but sometimes that's the path to the simple solution, is doing something kind of silly, right? And then optimizing later on in hindsight. Sometimes it's hard to conjure that knowledge and foresight. Okay, so what did I do here? This one looks like I got it during the contest. Actually, I got it in less time during the contest. each character count deleted. Okay, so basically the same thing I was coming up with previously. Deletions. Get this thing side by side here real quick. Scene sets. Oh, actually, looking at my old solution, I'm not even sorting. I'm just processing straight up. Deletions, I'll just crack as a total. It's interesting. About a year ago during contest, I solved this faster than I did today. I guess during contest, I'm a little more motivated to push myself to come up with a solution faster. Overall, though, it is a naive solution, right? It's not necessarily too crazy. Let's do this. Just delete that, and then let's do this. And use a map M as a counter of each character. Character C frequency in the input array of characters A. Tracking each count which has been seen to accumulate the total T deletions needed for each character frequency to be unique. Then JavaScript method 3 plus C++. Okay, so this guy seems overkill based on count. We don't need a separate variable here. We can just do this, right? Just keep it super simple. Just need to add the count as it bottoms out here. We only need that once, right? Pretty sure this will work. Let's try something bigger and let's see what happens. Right, so if we can reduce the code, we will. Otherwise, it's good enough, right? We need to be too simple. Okay, so let's do this. So where did my here? Oh no way! Did I just clobber what I was doing? Dang it! Paying attention to what I'm doing here, obviously. Oops, okay, well, start again. It'd be the first time I started over again. I don't know. Good typing practice, I guess. Try not to close it this time. Okay, there's that, right? Let's do that same solution in the other languages after I type this again, right? Ugh. Use a map M to count the frequency of each character. C of the input string of the input array A of characters. tracking each count seen, which has been seen in a set. Oops. Right, to ensure each count is seen. Right. To accumulate the total T deletions. Okay. And let's go back here to our other window. Okay, looks like, yeah, here's my previous solution, and I'm going to convert this back to here. Here's our array of characters, and then using set to be an unordered set of unordered set integers, and use a map as a counter. For each character of the array, increment the count of each character. And then for each character count in the map, I'll count, and cannot insert the count. So here, seen is a set, and insert is the function which returns a pair. The first of the pair is an iterator to the inserted or existing element, and then the second of the pair is a Boolean value indicating whether or not the value was inserted or not, right? So if it already exists, then it's going to be false. If it does not exist, then it'll return true. So we're interested in the false case where it already exists and we can't insert it, in which case we'll decrement the count and increment our total T deletions, which we accumulate in piecemeal fashion here and return at the end. Okay, and then it will be inserted and it can zero out. Okay, so I think that's the solution. Big money, no whammies. Let's see what happens here. Okay, that looks good. Okay, cool. And I feel that that's a little bit more concise of a solution than I came up with a year ago or so. So that's cool. Okay, and then let's do this in JavaScript. Should be able to fly through these other ones, except for Rust. Rust might give me a hard time, but let's see, 630. And then here's our array of characters. M is our new map. Actually, let's see, we can use low dash count. Pretty sure I wrote a gist because I don't really remember this. Okay, grouping by each count, and then object entries count by has split. Okay. Let's do this. A equals A dot split. Stick it into an array of characters like that. Just no, I don't think that's fucking, it doesn't matter. There's this scene, new set. Okay, and then we'll do let m equals object dot entries low dash, what is this guy? Count by A dot split. Let's see. This map for small input. So A should be 2, B should be 1. That looks good. All right. And then we'll create a map out of this, is it? No, we're good then, right? So console log m sub A should be 2. No. Should be a new map from this then, right? New map from the object entries. M.get A should be 2. I wonder why I don't have a new map then. I think this is wrong, right? Let me update this here real quick. M is a new, actually, hold on. Let's do this. Console. Oh no, I can't use low dash over here. New map. Works here, right? Okay. Whatever. Okay. There's our map. We can just stick this here too. Okay. And then let each character in its count of the map. If count or while count and scene dot as count minus count plus t of your total deletions. Turn here at the end. Here. Okay, something like that. 6434. Okay, the first test case is good. 4 minutes. It's the implementation in JavaScript, which is accepted. Yay. Okay. JavaScript, do Kotlin and Rust, and then go do some other studies here. All right, bar M is immutable. Oh, wait, hold on. M is A dot grouping by it dot each count. For each character and count in the map. Character count. These are total deletions, which we'll return here at the end. Okay, so here's our character counts. Okay, that looks good. And then do scene associated with this guy as a pair. Oops, mutable set of integers. Okay, and then for each character count in the map, while count exceeds 0 and scene contains the count. Actually, here we need to make ephemeral value because in Kotlin, we cannot modify this. Oops. Okay, this mimics a deletion. Scene to add the candidate. Okay, something like that. Okay, that looks good. Big money, no whammies. All right. That's cool. Okay, we'll do Rust and then call it a day. I saved the best for last. Oh, let's do this. Reset. I don't really want to look at it, right? And do it from scratch for practice. Okay, so here's our array characters. Let a equals a dot chars dot collect into a vector of characters. I can access. Well, no, I don't know if I need that, right? Let m equals use collections hash map and hash set map new mutable it's in set e0 turn t at the end here and for each character in the array of characters the object and location on maps of entry the borrowed character c or insert 0 is incremented by 1 character counts and then for character count in the map. See if this works. Just do a print and debug. Oops. Just do this. Okay. So for the simple input, all right, we have two A's, one B. You might complain about, right? Our insert, oops, insert 0. Oops. Mute and equals hash map new. It's going to complain about this hash set scene because I haven't actually inserted anything into it. It's not able to deduce it. C does not live long enough. Oh. Just clone it. Actually, I'm not sure if we need to clone it. We need to clone it? I don't know. That was good. That mute candidate equals the count. Well, scene that contains the candidate. Candidate exceeds 0. It's decremented by 1. Total is incremented by 1. That simulates a deletion of that character. Scene dot insert candidate. Okay, let's see what happens here. Scene in the scope. Oops. Something like that. Okay, that one looks good. Actually, the other ones are cool. And Rust is similar to Kotlin in that we need to have this ephemeral value. I don't think we can decrement the count directly. All right, so if we try to decrement the count directly, I'm pretty sure this is not going to work. Can't modify this is mutable. Yeah. Right, so we need to have an ephemeral value. Okay. So this is cool. Similar to Kotlin, it's a little bit more strict. Okay, so there we go. Use a map M to count the frequency of each character. So you have the input array A of characters tracking each count, which has been seen to ensure each count seen is seen once to accumulate the total T deletions. Okay, that looks good. I'll catch y'all later.